Isn't math better when you're solving riddles? Let's find out why the scientist created an exact duplicate of himself. I know, because no one else was so smart and he needed someone else to have a brilliant conversation with. Or no one else wanted to be his friend. Who knows? I guess we'll find out the real reason. This is scientific notation, and we'll start out with exercises 1 and 2. Choose the number that is written in scientific notation. So number 1, we've got this one, and this one. Of the 3, only 1 is written in scientific notation. You have the number times 10 to the something, a number times 10 to the something, number times 10 to the something. Okay, so they're all written in the basic form is correct. The next thing I need to look at is to make sure that there's 1 digit in front of the decimal. Ooh, we've got 2 digits, so it can't be that. All right, that's got 1 digit, so it might be that. That's got a 0. It's got to be a non-zero digit, a digit between 1 and 9. So it's not that one. So the answer to number 1 is this. Now, number 2, I'll let you do on your own using the same steps that I did. Now let's go down to numbers 3 through 6. Find the value of n. We'll do numbers 4 and 5 together. I really like doing these. These are easy. So take this big long number and we'll move that decimal all the way from here to here. How many digits are between where it started and where it has to be in scientific notation? 3, 6, 9, 10. So it's going to be 10 to the 10th power. Let's start with here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it is 10. We'll circle that. And then let's go on to number 5. All right, so this is going to be negative because it's a teeny tiny little number. So whatever it is, it's negative. I know that much. So the decimal ends up being right after the 8. So how many places do I go from here to here? 1, 2, 3, 4, 5. Negative 5th. Let me count one more time just to be sure. Got 1, 2, 3, 4, 5 digits. It is negative 5. Number 5 is negative 5. All right, so on to the next section. These numbers are already written in scientific notation, and we are going to write them in standard form. I chose these two because they have the same base number. This is going to be a big number. This is going to be a small number. It's got a negative. So I'm going to move this 6 places to make it bigger. It would be 8, 7, 5. Well, it starts here. So let's see. If the decimal starts here, we go 1, 2, 3, 4, 5, 6. Make sure. 1, 2, 3, 4, 5, 6. So make sure that nobody confuses those little dots I made for decimals. Be really careful about that sort of thing. There. So my answer is 8,750,000. And now number 11. This is a small number, so I'm going to make it even smaller. Right now it's 8, but it's going to be smaller than 8 when I move this decimal. We'll go 1. I think I got this down. So it starts off after the 8, and then I go 1, 2. So yes. Now I'll put a 0 in front of that because then it's more obvious that this is a decimal. All right, so let's find our answers. 8,750,000 and 875 ten-thousandths. This one. In the next set, we will be writing these numbers in scientific notation. I chose both numbers that have a 922. This is going to be a big number, so it'll have a positive exponent. This is a small number, you see, so it'll have a negative exponent. So I've got 9.22 times 10 on both of them, because they both have a 922. Those are the non-negative digits. All right, so now I have to put my decimal here to be in scientific notation, but it started here. How many places did I go from here to here? 3, 6, 7. 10 to the 7th. And now, my decimal has to be here, but it started here. So that's how many places do we go? 1, 2, 3. Make sure, 1, 2, 3. Okay, so it's 10 to the negative 3rd. And you understand why this is negative. You see it's a decimal, it's a tiny number, so you're going to have a negative exponent. Now let's see if we can find our answers. 9/2200 times 10 to the negative 3rd. Found it. 9/2200 times 10 to the 7th. Right here. Finally, let's do the bottom. It says to write these numbers in scientific notation. You might look at them and think at first that they already are written in scientific notation, but actually they're not. It's close, but it's not quite. So the best way, I think, to change these to scientific notation is to take what they wrote, see I copied it, put that in standard form. So the first thing I'll do is I'm just going to put it in standard form. It's 10 to the 8th, so I move the decimal to the right 8 places. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Let's make sure. Started here. 1, 2, 3, 4, 5, 6. Wait. Oh, start here. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we put my commas in. So much easier to see there. Now, that is in standard form. Now we'll go from standard form to scientific notation. Scientific notation is going to have a 1 point because you've got to have the first digit is a non-zero digit. 1, 6, 6, and then the rest are zeros, times 10 to the what? How many places does it have to go from here to here? 1, 2, 3, 4, 5, 6, 7 to the 7th power. See how I did that one? Now, if you understand how decimals move really well, you can go from here to here. But if you don't feel comfortable with that yet, then go from here to standard form down to here. Now number 22. Look what I did. I went ahead and copied it. From this, I will convert it to standard form. Decimal starts here, and I've got to move it back 12 places. So first 2, 1, 2. Oh, goodness. So I need 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so started here. We go 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, started here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, yeah, 12. I had 10 on the brain. There we go. I did it right. It's always good to go back and check your work. And if it doesn't agree, then check it again and see when you see the same answer twice. So here is this number, this very tiny number, in standard form. Let's take this tiny number and put it in scientific notation. So here's your first non-zero digit, 5. It's going to be 5.5 times 10 to the negative something. You know it's negative because it's an itty-bitty, teeny tiny number. Now how many digits between the decimal and where it started? Wait, not where it's, the decimal and where we had to put it to be in scientific notation. Here to here. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See a negative 11. $5.5 times 10, negative 11. See if we can find our answers. I hope I didn't make a mistake. That's never any fun, especially when I've got it in a video. All right, so we've got that and this. All right, so let's hope I did these right, and we'll go and match them. The directions say that the uppercase letter goes in the box containing the lowercase letter. So the lowercase n, that would be L. Lowercase h, that's going to be a J. All right, so lowercase d is W. Lowercase j is S. Okay, so we have lowercase e is A. Lowercase r is N. All right, let's see if we can. Now we've got lowercase x is U. Lowercase f is S. And then finally, lowercase k is T. All right. Here's what we've got so far. You take it from here.